Hello students, in this video lesson we will study about the formation of cations, which are the positively charged ions, and anions, which are the negatively charged ions. Let us first study about the formation of positive ions. If an element has 1, 2 or 3 electrons in the outermost shell of its atom, then it loses these electrons to achieve the inert gas electron arrangement of 8 valence electrons and form positively charged ion or cation. It is not possible to add 7, 6 or 5 electrons to an atom due to energy considerations. Now, the metal atoms have usually 1, 2 or 3 electrons in the outermost shell, so we can say that the metal atoms lose electron to form positively charged cations. For example, sodium having +1 charge, potassium having +1 charge, and magnesium having +2 charge. Please note that an atom having 1 electron in its outermost shell loses this 1 electron to form a cation having 1 unit positive charge. Similarly, an atom having 2 outermost electrons lose these 2 electrons to form a cation having 2 unit positive charge, and an atom having 3 valence electrons loses these 3 electrons to form a cation having 3 units of positive charge. Let us take one example of sodium ion. The atomic number of sodium is 11, so one atom of sodium will contain 11 electrons. The electronic configuration of sodium would be 281. Now, as we can see that sodium atom has 1 electron in its outermost shell, this is not a stable arrangement of electrons. So, a sodium atom is not very stable, it is very reactive. Now, in order to become more stable, the sodium atom will donate 1 electron of its outermost shell to some other atom. In this way, the whole M shell is removed and the L shell having 8 electrons in it becomes the outermost shell. By losing 1 electron, the sodium atom gets 1 unit of positive charge and becomes sodium ion, that is Na positive. Since the number of protons and electrons in the sodium atom is equal, therefore it is electrically neutral, having no overall charge. In the sodium ion, there are 11 protons but only 10 electrons because 1 electron has been given out. This means that in a sodium ion, there is 1 proton more than electrons. Due to 1 more proton than electrons, a sodium ion has 1 unit positive charge. The electronic configuration of sodium ion is the same as that of the nearest inert gas, neon. So, it is more stable than a sodium atom. Let us now see the formation of negative ions, that are anions. If an element has 5, 6 or 7 electrons in the outermost shell of its atom, then it gains electrons to achieve the stable inert gas electronic configuration of 8 valence electrons and form negatively charged ion called anion. It is not possible to remove 5, 6 or 7 electrons from an atom due to very high energy is required. Now, the non-metal atoms have usually 5, 6 or 7 electrons in their outermost shell, so we can say that non-metals accept electrons to form negative ions or anions, for example, fluorine and chlorine. The element carbon having 4 electrons in its outermost shell is also a non-metal, but it can neither lose nor gain 4 electrons due to energy considerations, so a carbon atom does not form ions. Please note that an atom having 7 electrons in its outermost shell accepts one more electron to form an anion having 1 unit negative charge. Similarly, an atom having 6 valence electrons accepts 2 more electrons to form an anion having 2 unit negative charge, and an atom having 5 electrons in its outermost shell accepts 3 more electrons to form an anion having 3 units of negative charge. Let us take an example of oxide ion. The atomic number of oxygen is 8, so its electronic configuration would be 2, 6. The oxygen atom has 6 electrons in its outermost shell, so it needs 2 more electrons to achieve the stable 8-electron inert gas structure. By taking 2 electrons from some other atom, oxygen atom forms an oxide ion, which is O2 negative, having 2 units of negative charge. The oxygen atom has an equal number of protons and electrons, so it is electrically neutral, whereas an oxide ion has 8 protons but 10 electrons. Since an oxide ion has 2 electrons more than protons, it has 2 units of negative charge. The electronic configuration of an oxide ion is the same as that of a neon atom, and so it is more stable than the oxygen atom. Now children, the atoms and ions can be represented in the form of electron dot structures. Only the outermost electrons of an atom take part in the chemical bonding. These are known as the valence electrons. The valence electrons in an atom are represented by putting dots on the symbol of the element, 1 dot for each valence electron. For example, sodium atom having 1 valence electron will be written as Na dot, and aluminium atom having 3 electrons in the outermost shell will be written as Al with 3 dots. Similarly, a chlorine atom has 7 electrons in its outermost shell, so we put 7 dots with the symbol, and the chloride ion has 8 electrons in the outermost shell, so we put 8 dots and write it as Cl with 8 dots and a negative charge.